In the first part of section 7.1 and in your first video for this section, you learned about some basic properties of what we call a normal distribution and a normal curve. We're going to be learning to work with a normal curve and use it to find the probability that a value falls within a given interval. Now, in order to learn how to do this for any normal curve, whatever the mean, whatever the standard deviation, we first have to learn how to do this for what we call the standard normal curve. All right, so I want you to note that what we're about to go through here applies specifically to a standard normal curve. Now, things to note about a standard normal curve: it always has a mean of 0 and a standard deviation of 1. And it is always made up of z-scores. So the values on the horizontal axis, when you look at your standard normal curve, will be labeled as z, and they'll have mean 0 and standard deviation 1. Now, in your first video, you also saw a formula for a z-score and looked at some examples of converting to z. We're going to do more of that in section 7.2. What I want to focus on right now is just working with values when they're already given as a z-score. Okay, so a couple of basic properties here. When we're dealing with the z-scores and we talk about the mean, which is the value at the center, the z-score that corresponds to any mean is always equal to 0 because that is your central value. Points on the horizontal axis to the left of the mean, right, which would be down here below the mean, are going to correspond to negative z-scores. Points on the horizontal axis to the right of the mean, so up here above 0, are going to have positive z-scores. All right, so let's talk about how we can go about finding the area under the curve for a given z-score. All right, if we are given a value of z, we want to find the area. What you're seeing here is a clip of a table. All right, now your tables are found when you're working your problems in ALEKS. One of the buttons looks like it has a histogram on it. Looks something like this. And if you click on that, it will take you to your statistical tables. All right, and when you open up those tables, right, the first page looks like this. It kind of gives you a rundown, right, on what's included. The table that we use for Z is table A2, the cumulative normal distribution. All right, so let's scroll down there. You got to go through some pages of the binomial first, but then you should come to table A2 and it says cumulative normal distribution. It spans 2 pages, right? You have a page here with negative z-scores. And then the second page of the table looks at positive z-scores. And when you look up a value of z in this table, it gives you the area, but specifically the area to the left of z. That's why it's called a cumulative, because it comes from the left. All right, so in your notes, anytime you see a little snippet of a table like this, that's where it is. All right, you would pull up your table A2 and you would reference this in that table. All right, so example 1, find the area to the left for a z-score of 1.26. All right, now I like to sketch mine out just to make sure that I'm clear on what I'm finding. So if I wanted to look at the graph here, I would just do a basic bell-shaped curve, label it z, 0 at the center because that is our mean, and then the z-score that I want to look at here is 1.26. So I'm just approximating, keeping in mind that, we go 3 standard deviations to the right based on our empirical rule. And what I'm asked to find here is the area to its left. So I want the area of this entire region to the left of 1.26. All right, that's what I'm being asked to find here, is the area to the left of 1.26. When you're asked for the area to the left, or when you're given a graph that shows area to the left, you're just going to take that z-score to your table A2. You're going to make sure this is a positive z-score, so make sure you're on the page with positive z, and you look up z on the outer edges of the table. So on the left-hand column, I'm going to look up the z-score just to the first decimal place. Don't round it, all right? Just only look up to the first decimal place. That'd be 1.2. The second decimal place is found across the top, and in this case, I would need to go to a 6. And where those two things intersect gives me the area to the left of the z-score that I've just looked up. All right, so approximately 89.62% of the z-scores are going to fall to the left of 1.26. All right, now, if I need the area to the right, I can still use this table, but I'm going to have one extra step because we have to remember that our table only looks at the area to the left. All right, so again, in this case, if I sketched it out, or just to know what it would look like, right, if it were given as a graph, I want to look at a negative z-score this time. All right, so negative, I'm going to be down here below 0. And again, I'm just approximating where the value falls. But this time, notice what I want is not the area to its left, it is the area to its right. So this time, I want to find the area for this entire region, shaded, but to the right of z. All right, now, I can still go to my table and look up the z-score, just like I did above, right? This is a negative z. So make sure you're looking on the page with negative z-scores. Look it up to one decimal place first. All right, so negative 0.5. Second decimal place, I'm going to find across the top, which is an 8 here. And where those two things intersect gives me an area, but I've got to remember in my table, it always gives me an area to the left. So in this case, if I want the area to the right, I need to flip that around. And the only way that I can do that is by subtracting the area from 1. All right, because the total area under the curve is equal to 1. You learned that as one of your properties in your first video. So if I want to change that direction and I want to go to the right, I'm just going to take that area left. I'm going to subtract it from 1. And that will give me the area to the right, which is what I'm looking for here. All right, the third case that you're going to be looking at here is finding an area in between. So notice here we have two z-scores that we want to look at. Okay, so again, if I start with a sketch here, or if I'm given a sketch, this is going to be a bell-shaped curve centered at 0. Both z-scores are negative, right? But notice negative 1.45, that's the most negative, so it's going to be the furthest to the left. And then negative 0.42 is going to fall somewhere between that and 0. And what I want to find here is the area for just this region in between those two values of z. All right, so what that means is this time I have two z-scores to look up. All right, they're both negative. You may have some cases where one's positive, one's negative, right? You just go to wherever you need to go in your table to look up each value. okay? And start with the larger value because it's going to have the larger area to its left. In this case, that would be negative 0.42. So to one decimal place, that's just going to be negative 0.4. Second decimal place across the top is going to be 2. And that will give me the area to its left at 0.3372. Now, if I just wanted the area to the left of negative 0.42, that would be my answer. But I'm not finished because I have a second z-score to look at. All right, my second z-score is negative 1.4. And the second decimal place has a 5. That's going to give me the area to its left at 0.0735. All right, to get the area in between, okay, because notice what the table gave me. It gave me this area, then it gave me this area. So if I just want the area in between, all I need to do is take the larger area, subtract out the smaller area, and that's going to give me the area in between. Okay, so if you need the area to the left, all you have to do is look it up in your table. If you need the area to the right, you're going to look it up in the table, but then subtract from 1. And if you need the area between, you're going to look up both z-scores and then take larger area minus smaller area. All right, now, what I want you to do at this point is I want you to pause your video and I want you to try these next 4 on your own. Okay, you got area left, area right, and area between. All right, you'll need to use your table. Okay, so if you don't have one already downloaded, then just go to Alex, open up one of your problems in section 7.1, and look for that button over there where the help tools are to open up your tables. Right, that'll take you to your whole group of tables and you can find that cumulative normal distribution. All right, when you're working in Alex, also a lot of times the problem will have a direct link to the table, but anytime it doesn't and you need it, you can just click on that icon from one of your problems in Alex. Okay, so pause your video here. All right, try these next 4. And then come back and check your answer. All right, now that you've worked through those 4 check your understanding problems, I want you to check your work with what you're seeing here. First one, you were finding an area left, so you just went to your table. Second one was an area between. So you got both areas and took the difference. Third one was an area to the right. So you went to your table and then subtracted from 1. And then fourth was another area between.